So we're going to look at some word problems in this video. We're in our similarity unit where we're talking about ratios, and then ratios being proportional, so that means they're equal. And we can use that to solve that fact to solve a lot of problems that involve things that you might things you might encounter in your life. Okay, so I'm going to go through the steps first, and then we're actually going to hop around a little bit in the notes, okay? So, steps to solving word problems. I think the first important thing that you want to think about is to identify the two items that are being compared, okay? All these problems are going to be a ratio. So I'm going to be comparing apples to oranges or girls to boys or something. Two things are going to be compared, money to an item, okay? And then the next thing that's important to think about is what are you actually trying to look for? Determine the unknown, okay? I'm going to look at these these two steps, okay? I'm going to change them up a little bit at one point. But so step 3 says to choose the correct scale factor, okay, based on what you're trying to figure out. And I'm going to explain what that means in a little bit of a second, all right? Once we have that scale factor, we're going to be able to multiply to answer the question, all right? Let's look at example 2 first, actually. So example 2 says the distance from Framingham, Mass. To Chicago on a map is 15 centimeters, okay? If the scale is 1 centimeter to 64 miles, how far is it from Framingham to Chicago, okay? So notice they've given us almost like a unit rate here. I know that there's 64 miles per 1 centimeter. There's my ratio. That's what they've given me, and I know that I'm comparing miles to centimeters, okay? Now let's determine our unknown. My unknown is how far is it from Framingham to Chicago? Well, that's going to be measured in miles, right? So I need to figure out how many miles I've gone. And they've given me that for however many miles it is on a map, I know it's 15 centimeters, okay? So let's actually use the scale factor to figure this out. The scale factor here, 1 times what is 64? The scale factor is 64, okay? If I know that I went 64 miles per 1 centimeter, I can use that same scale factor and do 15 times 64 and figure out that they are actually 960 miles apart. Okay? So that's what I mean in those steps when I say a scale factor. However, sometimes a scale factor is really hard to find, and it might not be the most efficient method to actually solve. Let's look at example number 1, okay? So example number 1 says, if 200 notebooks costs $275, okay? That's what I'm given. It's kind of a fragment. There should be a comma there. So I'm comparing 200 notebooks to $275. There's my ratio, okay? What is the cost for 50 notebooks? So what I'm actually going to have you guys do is I want you to set up a proportion. So if I know for a fact that 200 notebooks costs $275, the cost per notebook hasn't changed. So I can say 50 notebooks costs how many dollars? And we have to figure that out. Okay? But since the cost per notebook didn't change, I know that these two ratios have to be equal. And we can solve this using the cross product. I can do 275 times 50. That's 13,750. That has to equal 200x. Divide by 200. And that means it will cost me $68.75 to buy that many notebooks. Okay? So rather than finding an icky scale factor that multiplies, I just use the cross product to solve, all right? So let's do that again with the part B. Now I'm saying how many notebooks can you buy for $412.50? So I still have that ratio I know, 200 notebooks per $275. But what's important now is the notebooks is unknown, so my variable needs to go on the top. But I have $412.50, and I know these two ratios have to be equal. And let's use the cross product. So I'm going to multiply here, 200 times 412.50, that's 82,500 equals 275x divided by 275, and I get 300. So that means there's 300 notebooks. Make sure you have your units on your final answer, okay? All right, so let's look at example 3. All right, I'm going to loop 3, 4, and 5 together because these problems are a little bit different than examples 1 and 2, okay? Let's read example 3 and let's see if you guys can follow what I'm saying. At FHS, the ratio of students taking photo class to not taking photo class is 5 to 12, okay? If there are 2,142 students at the school, find the number of students taking the photo class, all right? So I want to actually think about what this ratio means. This means in words, for every 5 students taking photo, 12 students don't. What's different about this problem is they've given me, the information they're giving me to help solve 2,142 is a total number of students at the school, okay? I don't actually know how many students are taking photo class and how many aren't, but I know for every 5 students, 12 students aren't taking photo, okay? So what we can actually do is set up an equation. I can say that 5 times some number and 12 times some number will get me to 2,142 students, okay? And then we can just solve this equation from here. 17x equals 2,142 divided by 17, and I get 2,142 divided by 17 is 126. Okay? So what that means is if I take my ratio, I'm just going to start writing down here, okay? If I take my ratio 5 to 12 and I scale it up, the numerator up by 126, and I scale up the denominator by 126, I would get 630 over 1,512, okay? And so what I know is that I want to answer, find the number of students taking the photo class. Well, that came from the 5 students. So that means that 630 students were taking photo. And notice, if I do 630 plus 1,512, I get the total 2,142. So this ratio that they gave me in the beginning, if I can find a multiplier, right, I can use that to help me find the parts that will add to the total that they gave me. All right? I know that's a little bit confusing at first, but let's do another example, fill out, and see what we get. So Nick has 55 coins, dimes and quarters only, right? So he has 2 different coins, but he has a total of 55, okay, in his hand. The ratio of the number of dimes to the number of quarters is 3 to 8. So the 3 is representing the dimes, and the 8 is representing the quarters. So for every 3 dimes, he has 8 quarters. So I can set up the equation 3 times some multiplier, plus 8 times some multiplier of this ratio will equal my total of 55. Well, 3 plus 8, that is 11x equals 55. Divide by 11, and I get x equals 5. Okay? So let's scale this ratio up. I have 3 dimes for 5 quarters. I'm multiplying by 5, multiplying by 5, and that means I have 15 over 25. Okay? Now I made a mistake, which I just caught, okay, because I went to go add 15 plus 25, and that didn't add up to 55 coins. The ratio from the beginning was 3 dimes to 8 quarters, okay? So now let's scale that up. 3 times 5 gave me 15. 8 times 5 gives me 40, okay? So what that tells me is I have 15 dimes and 40 quarters. And notice 15 plus 40 is 55 coins in total. All right? We can use this problem to help us solve geometry type problems as well. So 3 angles are in the ratio 2 to 3 to 4, and their sum is 270. Okay? So I have 3 angles. One is 2 times some number. The other is 3 times some number, and the other is 4 times some number. But what I know is the sum, all 3 angles added together, the total, 2x plus 3x plus 4x, has to equal 270. Well, 2 plus 3 plus 4, that would get me 9x. 9x equals 270. Divide by 9, that means that x is 30. Okay? So the multiplier, 2 times 30 would be, this angle would be 20 degrees. Oh, sorry. 2 times 30 is 60 degrees. 3 times 30 is 90 degrees. And 4 times 30 is 120 degrees. Okay? So the angles are 60 degrees, 90 degrees, and 120 degrees. Okay? Good luck on your homework.